Okay, so this is the article titled What Eyes Can See. So, first paragraph and second paragraph. Look around. What do you see? Take a careful look at the objects closest to you. You might see a desk, your friend, maybe an apple. Are you really seeing those things? What you are actually seeing is light bouncing off the objects around you. The only thing the eyes can actually see is light. Light carries energy. When light hits a material, three different things can happen. The material can absorb the energy, which is take it in, transmit the energy, let it pass through, or reflect the energy, cause it to bounce off. Depending on the material and the types of light hitting it, all three things can happen at once. Go ahead and pause the video and summarize paragraphs 1 and 2. Starting with paragraph 3. These three possibilities determine the way you see. Light moves from a light source to your eye in a straight line, passing through some materials and bouncing off others, before light is finally absorbed by the back of your eyeball. There, tiny organs called rods and cones absorb energy from the light. This energy triggers a chemical signal with information about the color and brightness of the light. Depending on the wavelength of the light, different signals are sent to the brain. We perceive different signals as different colors. So your eyes are actually seeing light. Still, this does not explain why you see certain objects as certain colors. For instance, why are some apples green and other apples red? Red apples look red because they reflect red light. The energy from red light is not absorbed by the apple. It bounces off instead. When you look at the apple, reflected red light waves hit your eye and are absorbed. The energy you take in from these light waves sends a signal to your brain, which causes you to see the color red when you look at the apple. The process is the same for green apples, except green apples reflect green light instead of red light. Go ahead and pause the video and summarize paragraphs 3 and 4. Okay, we're ready for paragraphs 5, 6, and 7. So, paragraph 5. What about when you look at something black, like a crow, or something white, like an egg? People usually think of black and white as colors, just like red. To your eyes, however, black and white are different from the colors of the rainbow. Black is what we see when no visible light is reflected off an object. Black objects don't reflect any visible light because they absorb all types of visible light. Taking in energy from so many different types of light can make black clothes feel hot and uncomfortable on sunny days. White, on the other hand, is what we see when all colors of visible light reflect off an object. White objects reflect all types of visible light. White clothes are great for staying cool on a sunny day because they don't absorb energy from visible light. If black is the absence of color, what about things that appear to have no color, like a clear piece of glass? Clear glass seems to have no color of its own, but it isn't black either. When you look through a piece of clear glass, you see the colors of the objects on the other side. This is because clear glass transmits all types of visible light. When these light waves hit a pane of glass, they pass right through, carrying their energy across to the other side. Through a clear glass window, you see a world full of colorful objects, each of which is reflecting certain wavelengths of light through the glass to your eye. As you look around, what you see isn't really what you see. Everything you can see is just light reflecting off of things. The colors of objects are determined by the colors of light they reflect. If apples didn't reflect visible light, they would look black to us. And if our eyes responded to a different type of light with a different range of wavelengths, everything in our world would look very different. So pause the video, summarize paragraphs 5, 6, and 7, and then come back so we can look at the images. Okay, this first image shows light coming in. It hits the apple and it bounces off. This is called reflection. The next little bit, the light comes in and hits the apple and stays there, and it's represented staying there by this little yellow circle. This is called absorption. The third arrow shows the light going right through the apple. It travels straight through and comes out the other side. This is called transmission. So let's use this coding of angling, circle, and going through for the rest of the photos. Here we have all visible light, and it has all the colors: red, orange, yellow, green, blue, indigo, and violet. They all come down here, and you see, boom, absorbed, 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 and absorbed. The only one that is not absorbed is red, and so that's why when red bounces off, it's reflecting, and it comes to our eye, all we see is the red light because all the other colors were absorbed. Down here, this is showing a white object versus a black object. So with a white object, all the colors bounce off, nothing is absorbed. So when all of these colors together enter your eye at the same time, it appears white rather than like red, orange, yellow. It's all mixed together and shows up as white. For the black bird here, all the colors come in, and each one of these is absorbed by the bird, so nothing reflects back to the eye, and the bird appears black rather than any other color, because all the types of light are absorbed. This image shows everything happening. We have an eye, and it's perceiving this red apple through some clear glass. So all the colors other than red get absorbed. The red bounces off, it's reflected. It travels through the clear glass and enters the eye. So the glass is transmitting color. It doesn't absorb, it doesn't reflect, it transmits. And so it appears clear, and the red light just goes right through to the eye.